refresh this page and then these two things are close. We are live, sir. I just muted it. Yes, sir, we are live. You can start, sir. Please Google form questions.
So I have to unmute, right?
No, sir, not required, sir. You are live only, sir. Your voice, no? Students will be able to hear, sir. Otherwise, echo will come, na, sir. If you
Achha.
unmute, echo will come, sir.
They can hear me now.
Yes, sir.
Yes, it is live.
Yeah, hello friends. How are you? So it was indeed a great experience for me to continue with the second course. The second part of this course, Design of Fixed Wing UAV. So I have few questions here, few offline questions posted by your friends. I'll try to read them out and then say if I'll try to answer them. I'll see whether I can able to answer them or not. So the first question is from Ganesh Natarajan. He's a student. He's trying to ask what are the restrictions faced in UAV operations in regards of regulations from DGCA / other government bodies. No? At what level does those restricting factors affect the design process? In case if any UAV is designed or common mission plan is asked to be redesigned after evaluation of DGCA. Yeah, this is a very nice question. In fact, what we have discussed, we had very less discussion about this mission requirements. So mission requirements, whatever you are going to choose, has to reflect these DGCA constraints. No? So we can't design as per our wish. So these are set of guidelines which are available already. So you can follow those guidelines and then start designing your UAV, so that though you are given a mission to fly a UAV at a desired velocity and desired airspace, or say if that is not allowed by DGCA, then even your design is not going to get approved, isn't it? So you need to first consider these DGCA regulations during the mission requirements itself. So that is how you can see iterations are unavoidable, that is for sure. So in order to minimize those iterations, you need to consider these regulations beforehand, so that your design is more or less in a safer side. Okay. So I hope I might have answered you. But just in case if somebody is not satisfied with the answers, you can always mail me. So I am typing my mail ID here. So you can mail me anytime. So those who want to talk to me, I will also try to give my phone number as a reply in this mail. So you can all, those who have doubts, they can definitely mail me. So I would like to thank our TAs, team of TAs who actually helped me a lot. To start with Salahuddin Qazi and then Prabhajit. Prabhajit was instrumental in coming up with these beautiful videos. He was there all the time with me during all the recordings, so he has given his valuable time to me. So I am very much thankful for him. And then at the same time, Salahuddin Qazi is a bit senior with the system, so he really helped me a lot. And then Nitesh, so he is my PhD student. He is another beautiful guy. So I have got good time with them, and yeah, definitely. Yeah, I hope they might have also learned something from this experience, and I wish they should be useful for their career. Right? So, and then I'm moving on to the second question. Darahan GU is a student again. Effect of stalling in VTOL drones. So that was the question he posted. I'm not sure whether whether it is whether he completed the question or not. But to start with, stalling in VTOL drones, if you talk about a fixed wing VTOL, then the stall comes into picture. So when you talk about a multi-rotor VTOL configuration, I don't think we have much to discuss about stall. So the initial thing, or say you need to program it, maybe I try to answer this question, say during the phase where the transition happens from vertical flight to like forward flight, and then from forward flight to vertical flight while landing. So during these two phases, you need to, like, once you are not able to generate, or say you decided to land, then you need to stop generating lift from the wings, and then you have to depend upon, because you don't move at for required forward velocity, right? So you need to start developing thrust, or say a force which is acting opposite to the weight by means of thrusters, right? So these thrusters, in our case, they are like a brushless motor with a propeller combination, so which are acting in the vertical plane, right? So they are producing thrust in the vertical plane. So now you need to operate them even before the aircraft reaches stall, right? So that as a no, that is when you can indeed stop moving forward and then use those multi rotors and use that respective equations to control the drone to, so that it will come to a halt at a desired or say desired location where you want to start descent. So otherwise you can say, like, even before if the aircraft comes to a halt in terms of forward velocity, even before reaching that desired location, so this multi-rotor combination, like so you can still operate it in a multi-rotor combination and take it to a desired location and then start descending from there. So yeah, it is definitely an important aspect when it comes to stall of, like, when to switch on completely into a forward flight mode and when to switch on into a hovering mode, or say vertical climb or vertical descent mode. So that's an important aspect. So it indeed, stalling in VTOL for a fixed wing aircraft matters. So moving on to the next question. So Pratiman Day, he is employed already. So NPTEL sites are not working. I'm not able to see the videos at all. Please help, sir. I think that's not a problem at all. I request Preetham to talk to our TS. They'll be helpful. So some of you also, like one or two guys, also posted their difficulty in watching these videos, but it was resolved. Please talk to the team. So NPTEL team here is working day and night, so they are ready to help you at any cost. No? So please talk to them, so you'll be able to solve this issue. Okay. And Govardhan, yeah, he's a student. So his question is, my question is related to aerodynamic calculations of an airfoil. When finding the aerodynamic coefficients of an airfoil, how can we take its surface or planform area into consideration while it is an infinite wing? So we don't generally consider surface while calculating aerodynamic coefficients of an airfoil, right? So it's all. So that's. I think you need to watch those videos again to understand it better. No? There are no such considerations. We are not worried about planform surface when you're talking about infinite wing, right? Yeah. So Mr. Manoj Isaac is a faculty. In lecture 12, the power required during climb has been calculated as 296.5 horsepower. However, by substituting values in the given equation, that is not the value we get. Would be nice if you can clarify this calculation. Confusion is primarily with the units used. In a few other places where calculations are done, the units does not match because G was either ignored or included without mentioning. Okay. So yeah, I think our friend Salahuddin Qazi, I think he has solved this problem. So he is the right person to talk about this. Qazi, can you please help me? There is a doubt here. Can you please clarify that?
Hello, you are talking about lecture 20. The power required during climb has been calculated as a 296.5 HP. And however, by substituting the values in the given question, it is not the value we get. So maybe I can do the mistake. So I will check this and I will reply in the forum. So first I will calculate another if we are getting 296.5, and also you send me the screenshot of your calculation, then we will discuss there. So and write your mail ID also. If I can reply privately to also, otherwise I can reply to all in the forum. So thank you for pointing out this. Maybe I can do the mistake. I will figure out whether I have done mistake or not. And also you just share your screenshot of your calculation.
Okay.
Thank you so much.
Yeah, so there is a possibility of some small mistake. So please follow Kazi's instructions in order to solve this issue. Okay. No. Kanimozi. Kanimozi, yes, he's a student. So here are there are no questions from him. Okay. So Saurabh Kulkarni. So what is the difference between? He's a student again. What is the difference between simple propeller and ducted propeller? What are the effects of using a ducted propeller on the aerodynamic factors? No, definitely, so it, see, from aerodynamic point of view, I'm not sure whether this question is about how the slipstream of the propeller is going to affect the aerodynamic forces. If that is the case, yeah, near the fuselage there is always a interference of the slipstream, right, on the wing. So that's why you can see many pusher and puller configurations. So a pusher more or less have a clean flow compared to the puller configuration. So on the wings, especially on the wings. So there is an effect of this propeller slipstream on the wing in terms of aerodynamic forces on aerodynamic forces. But when you talk about this ducted propeller, again, in the ducted propeller, you are now constraining the flow, isn't it? So it is so it has a minimum area with increased number of blades. Ducted fan, to produce the same amount of thrust what a normal two-blade propeller or two-blade propeller does. So it has to have more number of blades, and then it has to create within a small area. It has to create huge pressure difference. That takes a lot of power. Power consumption is quite higher in case of ducted propellers compared to that of propeller brushless motors compared to that of normal propeller motors. Okay, and can we use dual output, okay, / dual shaft BLDC motor for a particular UAV application? Yeah, so this idea generally, if you are talking about coaxial motors, then they are mainly employed for say VTOL UAVs and multi-rotor UAVs. So I think it is a good idea. So it's a good idea to employ multi-rotor UAVs, coaxial UAVs for multi-rotor configurations. And then you need to see what is the ideal gap to like propeller ratio that gives you a what do you call it, efficient power consumption as well as good results comparatively. Because see, the one propeller is in the wake of the other propeller, then you need to properly characterize such a combination before using them. That is what my take on that. What should be the approach while selecting IC engine for UAV applications? So approach in the sense, again, so even whether it is IC engine or brushless motor, so the first and foremost thing that we need to understand is the systems requirement, right? We have figured out systems requirement from various examples that we have solved, and then once you know that, and then the main point is that when you have extended hours of flight, then definitely batteries are not a good solution, because you need to carry a lot of dead weight along with it. So definitely IC engine can be a very good solution when you talk about extended range flights, right? Extended flights with extended endurance. So what type of actuators are used for controlling the control surface of a UAV? So all these questions are from the same student, Saurabh Kulkarni. So yeah, and then what type of actuators? So we generally use servos, servo motors in order to control this actuators. So high torque servos. So it depends again what is the kind of hinge moment that you need to overcome. So selecting that particular actuator depends upon the kind of hinge moment, and then with the factor of safety. At all the flight conditions, you need to estimate what is the corresponding hinge moment and find out a servo motor which can hold the control surface at a given flight condition, at a desired location for a given flight condition. So yeah, which is again depends upon the kind of torque or the torque that the control surface is required, like what is the torque that we require to give in as an input to the control surface, so that it can be maintained at a particular deflection. right? So that is how we generally select a controls actuator. So in general we use servo motors as actuators here. So they are widely available nowadays off the shelf. So there is no need for us to reinvent the wheel here. So where can we learn about the electronics and programming of a fixed wing UAV? Can you plan a course for that? So that may not be a course, no. Electronics and programming may not be for UAVs. I think, in my opinion, it should not be a course. You develop it as you use it. So that may, we can't generalize such applications. Rather, I am planning for a course related to programming of so not exactly or embedded programming. It's about more about simulations of unmanned vehicles for various flight conditions. Starting with missiles. Missile is also an unmanned vehicle, right? So starting with missile, guided bombs, and then to say multi rotors to VTOL configurations and fixed wing hand launch UAVs. So I am planning to offer a course on simulation of unmanned vehicles, modeling and simulation of unmanned vehicles. Modeling here, it's about mathematical modeling, not again the CAD modeling there. So all this CAD, in my opinion, CAD modeling and then learning the programming of a microprocessor. So all these things are like a la carte. Like if you are interested, you can learn them. I may not be able to offer a course for that, but definitely for modeling and simulation of flight unmanned vehicles is a good idea to start with. So thanks for that. And then I'm doing a UAV project, so if required guidance, what are the means to ask the queries to sir or TAs after the course is complete? So I just told you, I have given my email ID, so you can post me there. I'll be more than happy to help you. Right? So what are the opportunities of internship at IIT and how do I apply for it? So you can talk to the NPTEL team here. You need to score a good, what do you call, you need to score well in the end semester examination or in the entire course, so that IIT-K will offer you an internship when you approach them, right? This NPTEL through NPTEL team. So there is another guy, Yashwant Chellamala Setti, yeah. So he's a research fellow. So so please don't mind if I might have read the name wrong, some of your names in a wrong way. Please don't mind for that. So he's a research fellow. Yeah, what he's trying to ask is, we humbly request you to conduct a hands-on UAV design workshop at IIT-Kanpur on payment basis. Because I believe that along with the theory, practicals are also required to understand UAV fabrication. Please take a survey in Google form about how many are in this course are interested in participating in UAV fabrication workshop. By doing this, students get experience and also workshop organizing committee will get funds. If in case this is not possible, please record videos while practically fabricating a UAV and upload it as UAV design part 3. Despite being EC student, I understood each and postscript, so each and every concept. Thank you very much for yeah, that's fine. So the thing is, again I told you, UAV fabrication, there are many videos readily available. So you need to have interest rather than it can't be it can't be taught. You can develop, or you can get it only by practice. It can't be taught. UAV manufacturing or fabrication can't be taught. In my opinion, I can't. So I was a good aero modeler right from my undergraduate studies. So I have that interest to develop models. So that is how I learned CAD. There is no need, in my opinion, the CAD, all MATLAB, CAD, so microprocessor programming. All these are not I mean these are all tools for you to help. So for you to understand a tool, I don't think it requires a course. It requires practice by yourself. It requires you take up a small problem in the first place, start building step by step. Eventually you can see you will be able to use the tool effectively. Whenever you are stuck with the bigger things, then you can take help of your friends who are already good at those. So that way, learning that way is far better than showing videos practically. I don't think I may be able to incorporate much technical knowledge through those manufacturing videos, other than just you be happy seeing me working all the day with the models, right? So next I would like to take a few questions here, which are in the chat room. So. Sir, can you provide some design insights about Boeing Loyal Wingman UAV and its interchangeable nose payload section? So this I heard it for the first time. I'm sorry that I may not be able to comment as of now, but I'll look into it and I'll get back to you. Right? So yes, sir. Please make a course on nose, fuselage, and tail design and selection in UAV design part 3 if it is possible. We can think about it. Right? Sir, how can we calculate the torque on the control surface for a given speed and maximum deflection? Yeah, you can do that. So since I thought of covering that, but again 20 hours is not good enough for our current task. So it requires to understand hinge moment coefficients, what we call it as CH alpha and CH delta E, right, and some factors that affects this hinge moment. So once we are able to understand for a given control surface, you will be able to calculate what is the corresponding torque required, right? So this I'll try to see how can I discuss a bit more about that. Okay, sir, I'm interested in he Jagadish Kumar. Sir, I'm interested in pursuing my masters in aerospace field, and it's really hard to find any information about the course offered. The current website is outdated in IIT-Kanpur MTech programs profile. Okay, for masters, so for this you can mail me separately. I can talk to you, right? I can guide you how to apply in IIT-Kanpur. If required, you can have a chat with me, right, or phone. So yeah, you can mail me, Jagadish. I can talk to you. Parthiban, Gana Skanda Parthiban. Good afternoon, sir. Good afternoon. How we calculate non-dimensional aerodynamic coefficients for a fixed wing UAV? Do we have any mathematical calculations other than CFT analysis? Please guide me, sir. Yes, of course. CFT is at much more or less the design is more or less freeze, right? So just to corroborate with the wind tunnel test results and all. So you have first principle calculations, analytical methods and semi-empirical methods, which helps you to understand about these coefficients for a given wing. Apart from that, using our engineering methods, what we discussed, you can also estimate some of the derivatives like Cm naught, Cm alpha, Cm delta E, right? Similarly, Cl delta E, and then say Cl alpha and Cl naught you can use from the aerofoil data itself. So yeah, for aerofoil data you depend upon experimental calculations, right? So at least the two-dimensional data. From there, using empirical and engineering methods, we will be able to estimate most of the derivatives. So if you have any questions, please try to post it here. We still have some time. I think I have run through all your questions. So please keep posting your questions. So Ganesh, he is asking about role of bio-inspired bio mimics in future UAV designs.
Biomechanics.
Yeah.
Maybe he's trying to say.
No, definitely. You see, there are like flapping wing UAVs which are already there is quite a good development. So Professor Deepobam Das from IIT Kanpur Aerospace Department, he works a lot in this bio-inspired UAVs. If those who are interested, they can contact him. Right? They have developed quite a good number of these flapping wing UAVs. So similarly, again, it depends upon mission requirements, in my opinion. So what are you going to use it for? How long you are going to use it for? How stable you expect it to fly? Or say, yeah, what is, again, it all converges back to this mission requirements. What are you looking at? So next question is from Nathan D. Souza. How does the gyroscopic effect when using a larger propeller affect the rolling stability of an aircraft, and what can be done to reduce this effect? Are you asking about the torque because of the propeller? So yeah, there is some destabilization for longitudinal stability, right? Because of the propeller, if you mount it, if it is a puller configuration, so there is a component of normal force in the direction of radial direction of the blade. So there is an effect, that destabilizes. Again, you design it in such a way that your Cm alpha is still negative, right? And Cm naught is positive. So I'm waiting for your questions. Yeah, if I have to answer Chillammala Shetty, Yashwant again, yeah. I think I spoke to Yashwant over phone, isn't it? I'm not sure whether he's the same guy or not. But sir, I would like to know in which area of ECE currently research is going on in IIT-Kanpur, and also is there any scope of UAV autonomous navigation in the future? No, see, I'm not sure in which area of ECE, right? If you're talking about electrical department, I'm not sure. You can go through the website and get to know from the profiles of the faculty what is their current area of research. So yes, UAV autonomous navigation, definitely we are working on that. Indeed, we want to have autonomous navigation based upon image sensing, image processing. So yeah, so for few defense applications. So if you're interested, you can write to me, you can talk to me regarding that. So yeah, Jagadish again. Sir, can you just list out the actual process and software used to design a UAV from design to testing? That can't be answered as of now here. Yeah. Okay. I may not be able to answer as of now. So yeah, the next person is Kabid Zaman. Yeah, Kabid, how are you doing? So sir, how to determine the sweep requirements in a flying wing UAV? Yeah, it's a tricky question. So the sweep requirement, sweep one way provides dihedral stability. 10 degrees of sweep approximately contribute towards 1 degree of dihedral stability for a UAV. So in general, I think I might have explained it in the previous course. So for a wing alone configuration, the sweep here will push the aerodynamic center behind, because the mean aerodynamic chord is somewhere behind the root chord itself, isn't it? So because of the sweep, so that pushes the neutral point of the entire configuration for a wing alone configuration, and the CG can be ahead of that very easily. So that's the main reason for sweep in a flying wing UAV. So how to know restricted airspace in India? Do we have some website app for it? So you can look at this DGC requirements, or DGCA handbooks on UAV. Yes, yes. To be frank, there are few what do you call guidelines by UGCA in designing UAVs, DGCA for in designing these UAVs, and they are now coming up with the what do you call it, guidelines for certification as well. And few companies have already got certified operations, no, few startups. So you can go through them, you can easily find them. If not, you can write to DGCA and their office of DGCA. So you can get feedback immediately, I guess. Derek, okay. Sir, how to start finding the aerodynamic parameters when we are given mission requirements like endurance, weight range, and only safe for flying wing UAV? As I told you, like I think this question was already addressed. Yeah, using this semi-empirical, again, go through our design algorithm that we have discussed earlier, using semi-empirical and analytical as well as our engineering methods, you will be able to address all those issues. And again, you need some experience in terms of like solving few performance problems as well as stability problems before actually handling this. Right? So I think Govardhan Golden. Govardhan is asking, sir, how the surface area is considered while doing calculations related to an aerofoil while we call it as an infile. You don't generally use surface area. I still this question is not clear. I think you posted it in during the offline what do you call it, conversations as well. But I don't think I get your question properly. If you can write a mail to me, that will be great. Gnana Pratibhan. So, sir, usually we are considering the complete UAV as a rigid body and deriving dynamics of it, but the actuators too have some dynamics. How do we derive separately and combine it with the rest? Okay, so no, so actuators have the dynamics. So when you use an actuator model, so the dynamics there talks about the lag, time delay in producing that actuation. So that's all you need to model there. Otherwise, it is rigidly fixed to the body. So that is not going to actually affect your what do you call it, rigid body dynamics. Yeah, while doing a system simulation, then you of course need to model the actuator, but assuming that it is again a part of the rigid body. Are you talking about the linkage between actuator and this control surface? If that is the case, yes, of course, based upon your maximum deflection and the torque requirement, you need to decide the location of the actuator in the respective linkage. So the transfer function you're talking about is what you're talking about here is during the control. As far as simulation is concerned, it doesn't matter. You can have a subblock, right, that talks about like once you know what should be the deflection, then what should be the what will be the delay, and what is the mode based upon the model that you're considering for the actuator. So there will be a delay in the response, right? So that is what it's going to reflect. So Kabit Zaman again asking, sir, what factors determine the size of end plate or other wingtip devices? So again, you need to taper the pressure. So at the tips of the wing, you have a pressure difference, right? Now you have to slowly taper the wing tip, isn't it? At the wing tip. So end plates is an abrupt ending, so that will also have certain drag, right? Addition of drag. So, but in case of say, if you properly taper it with the proper dihedral at the wing tips, no, by making sure that the pressure at the tips becomes zero, so that will reduce the drag. So it depends upon the size of yeah. So it depends, the design of wing tips depends upon the size and the plan form of the wing, right? Again, it can't be answered in a just in a single word, right? So there is a procedure with which we will be able to design an end plate or wing tip devices. So factors, again, it's mainly the cross-sectional properties at that particular location as well as the plan form. So there are Jagadish Kumar, there are many simulation and mathematical modeling tutorials and resources for multi-rotors. It would be of great help if you can help with the fixed wing UAVs. Yes, Mr. Jagadish. So as I told you, I'm planning to offer a course on modeling and simulation of flight vehicles or unmanned aerial vehicles. So in that, I hope we'll be able to address some of this, apart, including including how to process the wind tunnel data and how to estimate the derivatives from there and use those derivatives for flight simulation. So I would like to include all those aspects in that particular course. Any more questions? So again, there is a question from Derek asking me how do I get more experience in order to figure out the aerodynamic parameters from the scratch. Even in the problems, few aerodynamic parameters are given to begin with. Yeah, that's what. No, you first need to understand. As I told you, design is a synthesis of performance and flight stability and control, to be frank. No, so you need to have experience in terms of solving few stability problems, starting with the first principle. We try to address for the longitudinal case for some of the parameters which are which are required to complete our UAV design to syllabus. So then solving those examples will enable you with some of those parameters, initial parameters, and how to start with kind, and then you'll be able to solve them once you practice them. That is the only thing. It happens only by practice. So if you have to start, you need to start with courses on flight stability and control and aircraft performance. So Chelmar Shetty, Ashwant again, sir, could you please tell how UAV startups are doing that were incubated in IIT-Kanpur? As far as you know, is the business going good in those startups? Yeah, I can't comment about their business, but at least I can say there are many startups from IIT-Kanpur related to unmanned aerial vehicles, and most of them are doing good. So it all depends upon you. If you can deliver a good product, there is always a scope. No? And again, with the current campaign of Make in India, it is always a strong point, but again, it all depends upon the commitment. Kavit, sir, under what conditions power requirement during cruise will be higher than that during climb phase? is that or the part of week 7 content, and I had some confusion regarding this Khabib Zaman. So see, again, rate of we are talking about two different conditions altogether, isn't it? So in cruise, let us say if you want to fly at the maximum velocity, right? So the power requirement obviously varies, isn't it? So unless until we specify a particular flight envelope, which means uh, you have to specify the velocity of flights either in cruise or climb. That is when we can comment about which one is higher, during which phase is higher. That again depends upon the mission requirements. So we haven't actually discussed about maneuvering flight and all, isn't it? So there are other flight envelopes which we need to cover so that finally an engine can be selected. But we took a typical UAV flight envelope where it was not supposed to perform heavy maneuvers or say combat, right? So it was just needed to perform a typical takeoff, surveillance and landing mission, glide and landing mission, or descent and landing. Okay. So that is for those regimes we are able to estimate it, and depending upon the flight velocities and the flight conditions, the requirement even say let us say you want to climb at a very shallow angles and then at a very low climb rate. No, you don't mind if the say traveling say 5 kilometers or 10 kilometers just to climb about 1 kilometer, right? If you don't mind that, then of course the climb angle as well as climb rate is very less. So the power requirement may be comparatively less even when you want to fly at a very high velocity at no, in the sea level, at the sea level condition. So I hope I answered your question, Kavit. Yeah, Derek, thank you. And then Pratibhan, yeah, thank you very much. Do you think I might have missed any questions? So one announcement: if you have any of your friends who are working in embedded systems or what do you call controller, yeah. So if you have any, if you know somebody who works in embedded systems and then good at developing no, electronic circuit boards, so I kindly request you to ask them to contact me. I have few positions available for some of the projects that I'm handling. So I kindly request you to contact them. Yeah, I kindly request you to ask them to contact me. Okay. So Ashwant sir, can any of the modules in the projects you are working on be outsourced to any UAV companies, like developing a customized software or customized electronics? Yeah, see, whenever we think there is a limitation from our end, right, in terms of resources or say in terms of time, then we would definitely like to take help of others who are already other companies. So it is till 5 p.m. So sir, how to reach out to you again? No, I have my mail ID in all the lectures. You can mail me. Right. You can mail me again. I typed here, so I posted it in the chat room. So you can please you can send me a mail on this. Okay, good. If you are from avionics, okay, sounds interesting. So Roli posted, Roli Patak. I'm a student of avionics and would like to join your team for project. Yeah, definitely. I'll be more than happy if you can contribute hands-on in the project in terms of yeah, developing microcontroller boards for me, right? So for a particular mission. So I'll be more than happy to do that. So we'll talk. We can talk. Those who are interested, they can send me mail. So I think they are done with the questions.
Yes, sir.
I
If
guess.
questions are not coming in, then we
Yeah.
can conclude the session, sir.
So again, there is another.
Right.
Sir, could you please tell me the skills required for the electronics embedded systems course that you have just addressed? You can mail me, Yashwant. No, you can mail me. In fact, I think I have your number. Why don't you call me in the evening? Right? You must be having my number. I replied to your mail earlier. If you are the same Yashwant, no? If I'm not sure. Otherwise, you can send me a mail. I can again respond to you. I'll share my contact so that we can have a discussion. Right? So that I'll be more accurate in asking you about. Based upon your background, I'll also be able to understand whether that position can be of use to you or not. Sir, what are the differences between UAV technology and aerial robotics? Are any projects related to this in IIT Kanpur? Yes, many. On UAV, there are many projects, definitely. Aerial robotics, yeah. Say, again, you can name it anyway, the way you want. To be frank, what is the difference between UAV and UAV design and aircraft design? Not much, isn't it? Ultimately, yeah, there can be aesthetics and there can be other aspects, but ultimately both has to go through a critical certification in terms of flight dynamics point of view, right? So I don't think there is a much difference between, just because that we are working on a scaled down configuration, the physics is not going to change there, right? Compared to that of what we like you did for ages, like for almost few decades, no, isn't it? So aerial robotics, so they can give any name, when it comes to say a multi-rotor where the aerodynamics is not much, but flight dynamics uh, still an important aspect there, no? Even in aerial robotics, I don't see flight dynamics is far away from that. Yeah, thank you, Ashwant, and thank you, Jagadish. Atul Tripathi, thank you, sir, for the video lecture series. Enjoyed the way it's. Yeah, thank you, Atul. Thank you very much. I hope I can make better videos in the future. 9 more minutes.
But we can close, sir.
We
If
can-
questions are not coming in, we can
Yeah,
close.
I think no. So thank you very much. Thanks for the response. So I'm very happy that you liked the course. And then I would like to thank the NPTEL team and all other Santosh was another research staff in my lab who helped me for the recordings. He used to handle the camera. So and then NPTEL team is very 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 helpful in all aspects. So I'd like to extend my sincere thanks to them, and then to Professor Satyaki Ray as well. Right. So thank you very much.
Can we stop the stream, sir?
Yeah.
Yes.
Thank you, Nathan.